Instead, this week, I want to address the question, after having been neck deep in the pandemic data and the scientific literature and science Twitter for 2 years, what would I most want my best friends to know about the pandemic, especially for what lies ahead of us? So to start, I'm going to need to give a brief overview of how our immune system fights off viral infections. And it's truly fascinating and mind-bogglingly complex, but I'm just going to discuss the highest level parts in about 6 minutes. And I'm going to now share my screen. All right, those of us who have reached high school have all probably heard about something in our cells called DNA that defines our genes or our genetic code that makes each one of us unique. And each of those genes is an instruction for how to make a protein, how to make a molecule of protein. And our cells are constantly reading those genes to make proteins that are then used up to make our cells, which ultimately make us. And we have somewhere between 80,000 and 400,000 different types of proteins that our bodies make. Now, viruses also have DNA or a closely related molecule called RNA, as in the case of COVID, that describes the virus's genetic code. But the virus is not a complete cell. It has an outer shell of proteins, but none of the replicating machinery of cells. So for it to replicate, it needs help. And a virus's goal is to get into our cells, hijack the machinery of our cells so that more viral proteins get made, and those then get assembled into more copies of the virus. And it will do this until it's made enough of those viruses that the cell runs out of resources to make any more. And at that point, the viruses leave the cell by various mechanisms, including bursting open the cell in a rather harmful manner, causing disease. But a very important point of the interaction between cells and viruses is that most of the proteins in viruses are not equivalent to any human proteins. And our immune system's main goal is to find proteins that are not human-made and destroy anything that contains them. Our first line of defense is called the innate immune system. We have special cells in our body and our tissues, almost everywhere in our body, that are constantly at the ready to detect and destroy a small number of proteins that are very common in viruses. The moment you get a scrape, the innate immune system starts attacking anything foreign that it sees. And you'll know it's at work when you see swelling or pus. Pus is just a bunch of dead innate immune cells that have rushed to the area to fight. But the innate system only has a fixed set of generic tools to fight off viruses. And many viruses can evade those generic tools. So something more targeted is needed. So some of those innate cells head off to another part of our body, the lymph nodes, to recruit additional help. And they bring along parts of the virus and show them around to special cells called B cells and T cells. And it's like they take it to these cells and say, does this look bad to you? Does this look bad to you? Does this look bad to you? And these are part of what's called the adaptive immune system. These cells have receptors on their surfaces that can recognize only one specific portion of a protein, but there's roughly 100 million different configurations of those receptors. So most non-human proteins are eventually recognized by some B cell. And it can take a while, but eventually there's almost always a decent match. When that happens, the B cell gets hyperactive, it starts reproducing itself, and it starts generating lots of antibodies, thousands a second. And these antibodies are the same molecules that are on the outside of the cell, but now they're shot out into the bloodstream to head to the site of an infection. These antibodies then attach to viruses. And if the location they attach to is important enough for the virus getting into the cell, it might prevent it from doing so. And we call those neutralizing antibodies. But even if not, the antibodies still flag the virus for destruction. And other cells from the innate system recognize these flags and destroy the flagged viruses or infected cells. And the beauty of this adaptive system is that it lets your body ramp up gazillions of antibodies that are exactly what is needed to fight a virus, rather than just the generic tools of the innate system. And it also, by virtue of some other cells called memory T cells, remembers how to do it in the future for years, decades even, or even for a lifetime. Now, here's one of the most important things to learn from that process. The first time our immune system sees a pathogen is a virus, a bacteria, a fungus, or whatever, it takes up to 2 weeks for it to get into full attack mode. It needs to learn that it's there. It needs to figure out which B cells are going to work. They need to replicate. They need to get their numbers up. And it takes up to 2 weeks to get into full attack mode. But the second time it sees it, it only takes about 5 days. Now, why is that so important? Well, fighting off an infection, it's a numbers game. It's a race between how fast the virus can replicate its numbers and how fast your immune system can build up its defenses by replicating its B cells and T cells and antibodies, and to get up the numbers that it can kill off the viruses. Timing is everything. So at this point, I need to define 4 terms. The first is exposure. That's when you come into contact with a virus. It might take almost no time at all. Someone coughing in your face, a needle stick, touching a surface and then touching your eyes, inhaling air that has minute aerosols with viral particles in them. That's exposure. Infection is when viruses that have gotten in you have successfully gotten into cells and started replicating. If they're in one cell and replicating, you have an infection. And it happens so quickly after exposure, just hours or even minutes, that it's basically simultaneous. We get infected all the time, but many infections are quickly fought off by the innate immune system. And many infections are too small to detect with tests until the virus has replicated sufficiently. Third term, infectiousness. This is where you now have the ability to pass the virus on to others. This takes longer to develop than just an infection because 2 things need to happen. First, the virus needs to replicate enough that a large enough amount to expose someone else is available. And second, there needs to be some mechanism to pass it on to someone else. So for a respiratory virus, it needs to replicate enough in your nasal passages or your lungs, and then you sneeze or cough, or perhaps even breathe enough water vapor that someone else gets exposed. Then the last term is disease. And this is where you have some impairment of a bodily function. This requires that enough virus has replicated and is killing enough of your cells that the body is beginning to notice it, and some function of your body is reduced or otherwise altered. And maybe the very act of your immune system fighting against the virus, like your body raising its temperature in a fever, might be the cause of the symptoms. For our ability to successfully fight off a virus collectively as a society, 2 questions are really important to know. The first is, how soon after exposure is someone infectious? And the second is, how soon after exposure is someone diseased? So consider one of the great former scourges of the world, the smallpox virus. The smallpox virus generally took about 12 days from exposure until you experienced your first symptoms. And this little yellow part at the 12-day mark is where you first experience symptoms, which is disease. Symptoms equals disease. And importantly, somebody who had smallpox wasn't infectious until they started having symptoms. especially the rashes and blisters that would develop. And that at least provided some warning for someone to isolate without passing the virus on to others. Now, if you examine the timing, you'll see that the 2 weeks for the adaptive immune system to fully mount a first response is not fast enough to stop that person from getting diseased and becoming infectious, because the virus gets way too far ahead by that time. It's had, 2 weeks to grow in numbers. And by the time the immune system kicks in, it's too far behind in the race. But once someone has the immune memory from that first infection, only 5 days is needed to mount a response. And those 5 days, you can see it happens well before they get diseased or infectious. And so it's able to fight off that infection before they suffer any harm and before they infect anyone else. So if there was only a way that somebody could mount that awesome first 5-day response the first time they get infected with smallpox, instead of taking 2 weeks, well, that would save a lot of misery and lives. Well, in 1796, the British doctor Edward Jenner figured out that if you deliberately infected people with the relatively mild disease of cowpox, that would create immunity against smallpox. It would teach the body to fight smallpox in 5 days the next time. Now, if he had chosen horsepox, we might have called that medicine equines. But since he chose cowpox, he used the Latin name for cows to call this medicine vaccines. And because of vaccination, smallpox was eradicated in 1980 after having killed 500 million people in the last century of its existence, and hundreds of millions before that, for thousands of years. Now, other successful vaccines would follow. Let's look at some of those timings. Measles was infectious at 6 days and caused disease in 10 to 12 days. Mumps was infectious at 14 days and caused disease at 16 to 18. Rubella was infectious at 10 days and caused disease at 17 days. Because the 5 days to mount an aggressive defense is much less than the time to infectiousness and disease, those other viruses have largely ceased to be a concern in developed countries with widespread use of the MMR, measles, mumps, and rubella vaccines. And we don't even vaccinate against smallpox anymore because we've eliminated it because of vaccines. Now, wouldn't you like to know those same statistics for COVID-19? The original variant of COVID-19, you could get infectious after 3 days and diseased after 5 days. And some studies are suggesting that with Omicron, it's as short as being infectious in 2 days and diseased after only 4 days, starting to show symptoms after only 4 days. One of these things is not like the others. One of these things doesn't belong. I mean, that's a problem, isn't it? It really has significant implications, and it explains a lot of what we're seeing happening in the world right now. We saw first with Delta, and now especially with Omicron, that people who've been vaccinated can get significantly infected, and people who recovered from previous infections can get reinfected, even with symptoms. And that defied a lot of our collective expectations. But really, once we realized by mid-2020 that someone can be infectious just 3 days after exposure and diseased at 5 days, we should have expected this. The immune system only hits full stride in firing up those former soldiers at the 5-day mark. And it will slow the progression somewhat by that point, and it will very often wind down the symptoms very quickly and without much suffering. But it won't prevent all cases of infectiousness, disease, severe disease, and even death. So this leads to big truth number 1, which if you have your sheets, it would be on the reverse side of the sheet or the second page of what I sent out. Big truth number 1, COVID is here to stay. We're not going to be able to eradicate COVID like we did smallpox. The short time until infectiousness prevents that. On top of that, COVID also affects other mammals, as has been proven in cats, dogs, voles, ferrets, bats, hamsters, mink, pigs, rabbits, raccoon dogs, tree shrews, and deer. Since we will never get rid of these animal reservoirs, COVID will be with us to stay. And this leads right away to big truth number 2. We are almost all going to get COVID at some point, probably in the next 2 years. And I don't know about you guys, but I have known more people in the last 2 months that have gotten COVID than in the whole rest of the pandemic. It is really getting around. And this virus is very contagious. And the thing is, the more that people have immunity to it, the more we relax our mitigations because we want life to get back to normal. And those relaxations, coupled with big truth number 1, will ensure that it keeps spreading, hopefully without much harm, but it will keep spreading, and it will find almost everyone who wants to participate in normal life again. Already about half of the country has been affected at least once, and I expect we'll be over 80% by the end of 2022 and over 90% by the end of 2023. So expect to get COVID at some point. Now, big truth number 3. There is no guarantee that the virus will become intrinsically milder over time. Many people have been claiming that viruses tend to get milder over time because it's not to their advantage to kill their hosts. But if the infectious period starts well before the severe disease period, there's no selective pressure for the virus to get milder. Indeed, for COVID, many that die from it are no longer contagious in their final stages of suffering because they die from a cascade of events brought on by the virus that continues getting worse even after the virus is cleared. Big truth number 4. Your best defense when your turn comes is to have been fully vaccinated. While the vaccine may not fully prevent infection, infectiousness, or disease, it clearly reduces all those effects substantially. One shot of the vaccine helps a lot. A second shot helps even more, although it really should be after about 3 or 4 months for best effect. Since the current regimen is to get the second shot a month later, which is not optimal, getting the booster at 6 months after that is important as well. Now, big truth number 5. If you are concerned about the safety of the vaccines, you should be more concerned about COVID. And if you're not that concerned about COVID, you should be even less concerned about the vaccines. Now, let me explain that because this is a subtle but potentially helpful point for those who are hesitant or skeptical to take the vaccines, whether that is you or someone that you know that you're hoping will change their mind. It is rational to be concerned about the safety of vaccines. All vaccines have side effects, which are almost always short-term, but some can be unpleasant in very rare cases and deadly in super, super rare cases. So with any vaccine, you need to measure the benefits and danger of the vaccine against the potential danger of the infection, factoring in the likelihood that you will be exposed to the virus. So it's for reasons like that that we don't all take the yellow fever vaccine in the US. Unless we travel abroad, we have a nearly 0% chance of getting yellow fever. The chance of side effects in that case is much more of a concern. But if you're heading into the jungles of Ecuador, yeah, you're definitely going to want that vaccine. But when it comes to COVID, remember big truth number 2. We're almost all getting COVID at some point. So our calculation is easier. Is the vaccine reaction going to be worse than the COVID infection? Because I've had people say to me, I'd rather take my chances with COVID than with the vaccine. I'm young and healthy enough that COVID would be mild for me. But here's the thing, and it's subtle but important. When considering the chances of harm, there are not 2 different rolls of the dice, one for the vaccine and one for COVID. There's only one roll of the dice, and it is shared by both experiences because you have only one immune system. The vaccines work by inducing your cells to create a small amount of the proteins that the virus itself causes you to create. But in an infection, the virus also causes other proteins to be created. It also messes with your immune system to suppress part of the immune system and to put other parts of the immune system into overdrive. And then it replicates relentlessly doing this. The vaccines don't do any of that other stuff. They only do the relatively small subset of the virus's work, which is exposing your body to the spike proteins of the virus, teaching it how to fight off the virus. So if you expect you're going to have a mild reaction to COVID, you should expect to have an even milder reaction to the vaccine, because the vaccine is just a small, innocuous part of COVID. There is no separate dice roll. Conversely, if you expect you're going to have a bad reaction to the vaccine, that would only happen because some aspect of your immune system is out of step with the proteins in the vaccine. And it would also be out of step with those same proteins produced by COVID, but there's other proteins, the immune suppression, the hyperactivity, all those other problems that you'd have to deal with at the same time. And there is no separate dice roll. So if you are fated to have a bad reaction to either the vaccine or COVID, it is far better to experience that first with the vaccine, because it is in you for just a couple days and then it is done. It does not keep trying to pound at you as long as it can, like the virus does. So the final big truth requires reflecting a bit on our national conversation about COVID these last 2 years, because it has absolutely been the pits. In 2020, there were loud voices. There were sort of two loud sides in the pandemic conversation: those who wanted President Trump reelected and those who didn't. And both sides severely shaded the truth and engaged in exaggerations up and down, depending on how they felt their communications would influence that election. I could document many instances of this, but I'd rather just forget about that year. In early 2021, there was both a new president from a different political party, and more importantly, the first vaccines. That brought a third long-existent group into the public conversation, which is advocates against vaccination, so-called anti-vaxxers. That group's most vocal leaders historically skewed to the left in politics. But in this last year, they have found a more receptive ear on the right side of the spectrum, which is the side of the spectrum that I inhabit, by the way. And because of a change in presidency, we now have the strange situation where those most skeptical of the vaccines are generally those who are the strongest supporters of the president that put his presidency on the line to urgently create the vaccines in the first place. I'm telling you, our political conversations these days are just messed up and disgraceful. One main thing that has characterized both sides is the making of exaggerated, absolute statements. So for instance, on one side, you might have President Biden in a CNN town hall saying, "You're not going to get COVID if you have these vaccinations." There's literally no chance that could be true of vaccinations that are only 95% effective, since at least 5% of the people by definition are getting COVID. It should not be an absolute statement. On the other side, there are voices generally from conservative commentators, but not exclusively, saying the vaccines don't work at all. They don't stop infection. They don't stop transmission. They're not even a vaccine. These sorts of absolute statements are good for clicks and riling up people on your side, but they are invariably not correct. When you make an absolute statement, it only takes one counterexample to disprove it, and there are always millions of counterexamples to these. So this leads to big truth number 6. Most statements about COVID mitigations are never perfectly true or perfectly false. They should be understood as probabilities. Vaccines don't prevent 100% of infections, but they significantly reduce their progression. Vaccines don't prevent infectiousness, but they reduce the strength and length of time of that infectiousness. And vaccines don't prevent serious disease or death, but they drastically reduce the chances of that happening. It's the same with masks. We now hear people saying cloth masks are useless because COVID is airborne, which must be a bummer for Becky to hear, having made 600 of them. But even a cloth mask will catch quite a bit of what comes out of someone's mouth when they cough or sneeze, and that is helpful. It's not as helpful as a surgical mask, which isn't as helpful as an N95 mask, which isn't as helpful as a fully enclosed positive pressure hazmat suit. But the perfect doesn't need to be the enemy of the good. Every bit helps. It is not the case that if everyone masked with N95s, we would have stopped this pandemic. But it's also not the case that all this masking has been completely useless. The truth is somewhere in between. Now, right now, those on the political left seem focused on minimizing infections, primarily by wide vaccination and masking. They seem to have a far greater fear about the dangers of COVID and a willingness to impose mandates on everyone for the general good. And a good deal of their communication have been so-called noble lies, although noble half-truths is probably more accurate, to try to maximize the number of people getting vaccinated. And many of those noble half-truths have damaged our discourse significantly. Those on the political right have been characterized since the last presidential election by deep skepticism of the government, less fear about the health consequences of COVID, and a greater desire to return to normal life, and insisting on personal autonomy over masking and treatment decisions. The strength of those feelings has caused many, and I remind you that these are my political bedfellows, it's caused many to latch onto pretty wild, inaccurate claims about the vaccines in particular, but also about other data about COVID. If we had healthier politics now, we could have had reasonable discussions like weighing the anti-exposure benefits of masking against the detriment of not seeing each other's faces, particularly for kids in their schooling. But so much now is about wanting to bolster your own side and tear down the other side. So most people stake out extreme positions with no compromise. Christians should lead the way as peacemakers. But my sense is that we've been no better collectively than others in the current climate, and we may be even worse in some ways. So in hopes that we might be salt and light, I'll end today's message with two scriptures. The first is Romans 12:18. If possible, so far as it depends on you, live peaceably with all people. I remember a great brother, Phil Arendt, back in my Amherst days, pointing out that it doesn't say, so far as it depends on the other person, or so far as it depends on both of you, but so far as it depends on you. You can't control how other people behave, but only you yourself. And you can't guarantee that mutual peace will be achieved, but you can make the one-sided effort to live at peace and honor the scriptural command in doing so. It will aid you in doing this if you don't jump to the conclusion that someone you disagree with has the worst possible motives in mind. In all likelihood, they have a different set of fears than you, and they have confidence in different things than what you have confidence in. And their opinions make logical sense in light of that. It is far less likely that they're trying to impose a new world government or something like that. They just disagree with you. But what if I know that I'm right and the other person is wrong? Well, Paul addresses that in an interesting way in 1 Corinthians 8. He is discussing the eating of meat that has been sacrificed to idols. And he knows that there are many believers that are very uncomfortable with that and even think it's sinful. Yet he makes it very clear that it's acceptable to do so. But then he says this in verses 9 and following. But you must be careful so that your freedom does not cause others with a weaker conscience to stumble. For if others see you with your superior knowledge eating in the temple of an idol, won't they be encouraged to violate their conscience by eating food that has been offered to an idol? So, because of your superior knowledge, a weak believer for whom Christ died will be destroyed. And when you sin against other believers by encouraging them to do something they believe is wrong, you are sinning against Christ. So if what I eat causes another believer to sin, I will never eat meat again for as long as I live, for I don't want to cause another believer to stumble. I think of that verse a lot when I consider masking. There are situations like being outside where I'd rather not do it, where I'd rather not mask because I know in that particular situation, there's very little benefit. But if I see someone wearing a mask, I'll throw it on for their sake. It's just not an important enough issue that I need to provoke and win an argument. I'd rather live at peace with someone and have opportunities to discuss anything other than COVID and masking and vaccines with them, like maybe the gospel for once. Amen.